Hello. Yeah, I've been going through the projectiles, the vertical projectile motion and the horizontal projectile motions, and the projectile motion that is launched at an angle. So, in conclusion, there are formulas that are used to calculate questions containing projectile motion. You find that in most cases, be it A level mathematics or university mathematics, these formulas are actually provided for you to use. So for a particular particle which is projected from a point on a horizontal plane with an initial velocity of u at an angle alpha above the horizontal, and that moves freely under gravity, that is g is equal to 9.8, would say the time of flight taken is just given by 2u sine alpha g. So the time of flight, we are referring to the time, this time here t, from this point of projection up until the end. That's the time of flight. It is given as t is equal to u sine alpha over g. And the time to reach the greatest height, which is the turning point where it is a temporarily stationary, is given as u sine alpha over g. And the range, which is the distance r from the point of launching to the end, is given as u squared sine 2 alpha over g. And the equation of the trajectory, which is the equation that defines the displacement, is y is equal to x tan alpha. There are various versions of these formulas, but these four formulas are very, very crucial. So I'm going to do two examples to prove how these formulas have been generated. So let us look at the first two through an example. Here is an example. It says a particle is projected from a point on a horizontal plane with an initial velocity of u at an angle alpha above the horizontal and moves freely under gravity until it hits the plane at a point B. Given that the acceleration due to gravity is g, let me just put an annotation here and say g is pointing downwards. In this case, I'll always prefer to make it negative, since the launch is launched up is the positive direction. So as a result, g is going this direction, and the distance from A to B is what we call our range, which is just given by, denoted by r. And the velocity of projection, which is the initial velocity, so this is your initial velocity, which is given as u. So we are going to calculate the time of flight, which is t. At this point here, what is t? So what are we going to do? Let us resolve the forces that are involved here. First of all, we've got the horizontal movement, which is this direction, and I would say we call this u of x, and it is equal to u cos alpha. By now you would just write this, and this is u of y, and it is given as u sine alpha. If we resolve upwards, if we resolve upwards, so for A, to find the time of flight, we want to see how this has gone, how much has it taken to get to B. So we rather find we rather find the displacement of r, or we can use the horizontal displacement as well. I think that will work as well. Since we know, let us say let x be equal to the horizontal displacement. Actually, that's what Isaac Newton did when he was doing his kinematics theories. He would call this x. So since we know that the horizontal distance is moving, because the particle is moving at a constant velocity, because acceleration is zero, on the horizontal side. X can just be equal to which is the distance is equal to speed times time, which is just going to be equal to u cos alpha times the time. So x is equal to u cos alpha t, which further implies that t is equal to x over u cos alpha. So this is another version of finding t using the horizontal displacement. So in this case, I have resolved horizontally, that's t. But you find that most of the parameters, variables that are given here are on the vertical part. So to resolve t using the vertical part, it would look like this. We have the initial velocity, which is going at u sine alpha. We have the displacement for t from this point to this point. We have s is equal to 0 because it retains, remember, displacement is a vector quantity in this case. We also have acceleration in this case, which is minus g, and we've got t, which is big T. The equation that we can use here is sy is equal to ut plus half gt squared. This will give you s, which is equal to 0, u, which is equal to u sine alpha in brackets with a big T plus half g big T squared. So when we factorize again, this further implies that t is u sine alpha plus half g t is equal to 0. This gives us t is equal to 0, or u sine alpha plus half gt is equal to 0. So this is when t is 0, this is the start of the flight. The start of the flight, rather not the flight but the trajectory. This will be the start of the trajectory. And when t is equal to this equation, which can be manipulated to t is equal to minus u minus, actually it can't be minus u here, it actually has to be plus. Why? Because as we were resolving, g is negative, it's going down, g is negative. So this is a mistake, g is negative. So this will be actually equal to half half. So I've just made t this up the formula quickly. That was too quick. Let me just go through step by step. This will be half gt is equal to u sine alpha. This further implies that t is equal to 2. So we multiply it by 2, u sine alpha over g. And if you could see, this is the time of flight, which obviously is the same as x u cos alpha. However, if you see this, this is the formula that we are trying to prove here, which is given here as t. This is our t. So the first part has been proved. The next part will be to calculate the range. So the range is the distance from the point of launching, to the end. So the range will read, we are going to resolve horizontally. So we said, because we know that speed is velocity horizontally times time, and this is equal to, so that means this is not speed, actually this is distance. This is going to be distance, which I can call r, is going to be equal to velocity on the horizontal times t, which is going to be equal to u cos alpha t which is just tu cos alpha. So the distance here, or I can call it s in this case, should be defined as s is equal to tu cos alpha, and using t equal to 2u sine alpha over g as proved above. This further implies that s in this case, which is equal to 2u squared sine alpha cos alpha um, all over g. But remember our s here, let me just clean this part. Our s here is the range. This will be equal to 2u squared 2 sine alpha cos alpha over g. And since you have done double angles, you realize that sine 2 alpha is the equivalent to 2 sine alpha cos alpha. You do this at some point in time for Pumet's in Pumet's trig. So as a result, we get to a point where we say R is equal to u squared sine 2 alpha over g. Proved. As you can see, this is the formula that is calculating range. Now we're going to move to calculating the time of flight and as well as the equation of the trajectory.